Okay, we're going to get the equation of a parabola given its vertex and another point that's on that same parabola. So we're determining the equation of the parabola if its vertex is at 4, 9, and it goes through the point 2, comma, -1. So I always start with what I know about the vertex form, which is y equals a bracket x minus h all squared plus k. And I know that the h and the k are the vertex of my parabola, so I can change the h into a 4 and the k into the 9. So my next line will be y equals a x minus 4 squared plus 9. So we're just substituting our vertex in. The next thing we're going to do, we don't have the value of a, but what I do have is an ordered pair that belongs on this particular parabola. So like we did with the equation of the line, when we knew the slope and we knew a point, but the point wasn't its y-intercept, we could sub the x and the y into the equation for the x and the y and then solve for the b value. We're going to do that here as well. We're going to take the x value and replace it with 2, and the y value will get replaced with -1. Oops, that was supposed to be y value will get replaced with -1, and then we can solve the equation for this a value here. So where I have y, I need to replace that with -1. I'm going to leave my a. My x is going to get replaced with a 2 because that's the x coordinate of the vertex. And we end up with this. And now we can start to solve that for the letter a. Now I'm going to actually simplify inside the brackets first before I start to solve. So 2 take away 4, that would be -2, which is then squared. So exponents will happen next. -1 is equal to a. That's going to be times by 4 plus 9. And now I'm ready to start solving. I can subtract 9 from both sides. So I'll have -10 is equal to 4a. And then to get the a by itself, it's being multiplied by 4. So to undo that, I'm dividing by 4. That gives me that a is equal to -5/2, or -2.5. So therefore the equation is y equals -5/2, or you could take that to its decimal form if you prefer. And then we go back to the equation that we had right here before we actually substituted the x and the y in. So we get y is equal to -5/2 x minus 4 all squared plus 9. Now, taking a look at the next example. Does the point 2, 7 lie on the parabola y equals 2 bracket x minus 1 squared plus 5? Again, what we did before with lines, we did a left side, right side check to see does a point lie on a line. Same thing happens with the parabola. What's on the left side of the equal sign in this particular example is just the y, and what's on the right side of the equal sign is a 2 bracket x minus 1 all squared plus 5. So at this point I'm going to sub in my x for x and my y for the y and see does the left side actually equal the right side. So y has a value of 7. I have on the right side 2 times a 2 minus 1 squared plus 5. Now I can put that into my calculator in one foul swoop of a calculation, but I'm doing this in my head, so 1 squared is 1, but then 1 times 2 is 2, 2 plus 5 is 7. So right now we do have the left side being equal to the right side, which means, therefore, the point 27, does lie on the parabola. Lies on the parabola. And that is all good.